Okay, so today's question is matrix similarity after cyclic shifts. So you are given an m cross integer matrix and an integer k. The matrix rows are zero index. The following process happens k times. Every even index rows are cyclic shifted to the left. If we shift this 1 2 3 to the left, so 1 will come at the last, 2 will go at the front, and then 3. So it will become 2 3 1. And if the odd index rows are cyclic shifted to the right, so this 3 will come first, then 1, and then 2. So this is what we will get. So we have to return true if the original modified matrix after k step is identical to the original matrix, and false otherwise. So let's try to code this. What we will do, first take the length of the how many rows are there. So n is equal to len of mat. Now take the number of columns, nothing but the len of mat of 0, first one. Now as you can see, if k is 4, okay, and number of columns is 3, so it will be, the rotation will be equal to the first rotation. Okay, if k is equal to 3, number of columns are 3, then after rotation both will be same only. So let's take the small value of k, so k modulus is equal to n. Now this will be always from length 1 to n. Okay, so now let's go. So let's get a loop for I in range m, for j in range n. So now in place of rotating the matrix, what we will do, we will check whether the elements are equal or not. Suppose if k is given to us is 1, okay, if k given to us is 1, so after one rotation, what will be the first index of the matrix and what is the current first index of the matrix? If both are same, we will continue, else we will return false. Suppose if here the original matrix first index is 1, and after rotation original matrix first is 2, so both are not equal, we will return false. So let's do that. If I modulus 2 is equal to 0, so if we have to do the left shift, so if mat ij is not equal to mat I, which index will be at this index after one rotation? Of course the second one. Okay, so how we will get the second index? Nothing but the value, the index of this plus the k gives us the index which will be at this index after the kth rotation. So we will check are they equal or not. If mat of ij is not equal to mat of j plus k modulus n, which means the final and the first ones are not equal, so we will simply return false. Similar case for the odd rows. So else if mat of I j is not equal to mat of I, and here in place of j plus k it will be j minus k. Okay, and yeah, modulus n. So we will simply return false if those are not equal, means the final, and if any of the index is not equal, means the matrix are not equal. So, and afterwards if it does not return anything, it's getting equal at each cell, so we will simply return true. So let's try to run this and check if this works. Now so test cases has passed. Let's try to submit and check. Okay, so our code has passed successfully. Thank you for watching.